Hello, my name is Stephen Gottlieb and I made up the Calc 2 video. At this point I would love for you to sit back and view the sample demonstration that I made up. That way you get to see a little bit about my teaching style. We're going to solve an integration by using the technique called by parts. Suppose you wanted to integrate x times ln of x dx. And we're going to do this by parts. Now, this whole mess, some of it's going to be called u, some of it's dv. This on top is the formula for integration by parts. So, I call something u and something dv. Let's make believe for a moment I've already done that. So, I know what u is, and I know what dv is. But I need to know what v is. Well, if you integrate dv, you get v. So whatever I call dv, I better know how to integrate it. And now we have v, because we integrated dv. But I need du. I don't have du. Whatever I call u, I have to know how to take the derivative of, or the differential of. So now I look at this product, x times x times ln x dx. I want to call part of it u and the rest dv. So what if I call x u? I know the differential of x, it's 1 du. I even know the differential of ln of x, it's 1 over x dx. Wonderful. So in theory, I can call anything u. I can call x or ln of x u. But do I know how to integrate both of these? Do I know how to integrate ln of x dx? And the answer is not really. Actually, I have to do that by parts. But I know how to integrate x. That's x dx, excuse me. I'm going to call this dv. Why? Because I know how to integrate this, and what's left over, ln of x, I know how to take the differential of. The differential of ln of x is 1 over x dx. That is dx over x. And the integral, if I integrate both sides, the integral of dv, just like the integral of dx is x, the integral of dv is v. And the integral of x dx is x squared over 2. Sometimes when you do this integration, you really have to say a constant, like x squared over 2 plus 7. And it'll probably have to be 7. Otherwise, it wouldn't work out nicely. Okay, due to lack of space, I'm going to continue up here. You get u times v, dx over x, ln of x times x squared over 2. Now, if you write ln of x, if you write ln and then x squared over 2, somebody might think you're taking ln of the product of these two. So, to rule out that, instead of writing u times v, I'm going to write v times u. V times u minus the integral of v du. X squared over 2 is v, and du is dx over x. Okay. I'm going to erase what I have down here, just to gain some space back. Okay, so this is x squared ln of x over 2 minus the 2 in the bottom, I'll factor out as a half, and then you have x squared dx over x. But x squared over x is just x dx. So this is equal to x squared ln of x over 2 minus 1/2 the integral of x dx is x squared over 2 plus c. Now, this denominator in this term is 4. This is 2. If I double the top and double the bottom, I can factor out a quarter. I also have x squared. So I'm going to factor out x squared over 4 and x squared over 4. There it is. And what's left over is what I didn't circle. 2 ln of x minus 1 plus some constant. If you actually wanted to check this, you can take the derivative of the answer and you should get back x ln of x. If you don't, I made a mistake somewhere, but I'm sure this is right. This completes the sample demonstration for my Calc 2 video. I hope you enjoyed it. Hope you learned a little bit about solving integrals by parts, and I wish you success in your course, and again, thank you for viewing my video.